I will talk about some perspectives on the current work for going a bit further with interactivity in audio sequencers. So this is by using two tools. One is iScore, which is an interactive sequencer that has been developed at the University of Bordeaux. And the other is LibAudioStream, which is basically a sequencer as a library and has been developed at Grenoble, also in France. So first, I will make a small introduction. I will give some technical details, the method, and I make two small demonstrations. So first, what can we see here? A lot of stuff. This is basically all these pictures mashed up, and this is to see that there is a lot of similarity between all the different DAWs. Mostly we can see that on this part there is always something like track control, here some volume automation, effects, and what matters for me is like what happens here, where basically the timeline. What can we put here to add some interactivity? So if we talk a bit about the existing context, so most DAWs use a skeuomorphic approach to user interface. This means that they take roots on the tape recorder decks and stuff like this to build their user interface. And this makes sense because it helps to pass from one to the other. And then if we want to create music with interactivity, the other side of the spectrum is all the data flow software, so Pure Data, Max, Open Music, which is static, but also use data flow mechanism. And it now has a reactive mechanism in the last version, I think. All the music programming language, so with textual input, basically. And sometimes you have text and something else. You have different metaphors and paradigms of user interface to use. And finally, we can extend to all the instruments that try to reach toward add some sequencing inside. So it's really a vast spectrum. And most provide some capability to extend themselves by plugins or addition of your own computer code. So the question that I will ask is, what if we start from traditional sequence, so we put a sound. What if we add another sound? So for now, nothing particular, nothing spectacular. It's just two sounds playing one after the other. And we could also try to use the second dimension, the y-axis, to, well, make tracks, so still nothing exceptional. And then the question of interactivity arises, and one answer to this is to say, when do I want to run things? So for instance, you could say, I don't know when this sound will end, so let's defer this to runtime, to the performance time. So after that, I can, of course, continue on another sound, which will play in parallel with itself. Two sounds will play together, they will be mixed. But maybe, actually, this sound I only wanted to play if something particular happened, like I played some note on my piano, I have my gesture sensor that is in some position. And maybe it's the case for the other, so I basically want to implement a switch case in my graphical sequencer. I might also like to have some features to loop. So for instance, I would like to play this sound and again until it's finished. And of course, automate some parameters on my sound effects, which is here again something that you cannot not have in a audio sequencer. But then automation are useful, but sometimes you also want to say, okay, I want this parameter to be linked in real time via a transfer function to this other parameter. And for this, you will use a mapping function that will run so from here to here, which will take an input, here again, audio, OSC, MIDI message, or whatever protocol, and it will output another message and it will send them to the network or to itself. And sadly, sometimes straight curves, or not straight, but still curves, are not enough. So you could also use JavaScript code embedded in this core to directly write programs to control your parameters. And this code will run, for instance, at each tick from here to here, and then you will move on to other thing. So another interesting feature of audio sequencers is hierarchy and grouping. So nowadays, DAWs without group tracks are, well, let's say they're not common. So, but it's generally, not always, but generally one level of hierarchy. So you have one group track and then you have stuff inside. But you could also like to go to nest deeper and deeper and deeper, a bit like you will with your max patch that will open in another window. And to go back to our temporal features, well, you would also like sometimes to have two sounds that play, that don't play, and then afterwards resynchronize the audio until, well, something happens, like I said, some parameter changes or something like this. So this is iScore, so a software originally for interactive show control. So when I started this project, iScore was only meant for parameter control. It started mostly as a sequencer for max MSP, so you will control the parameters of your patch, but the software will not produce sound. And the LibAudioStream was a library for sequencing, but let's say rigid sequencing, like you could put mix tracks together, put them in parallel, apply effects, stuff like this. So I also added some extension that I will explain afterwards. And this work incarnates in an audio plugin for iScore. So basically all the audio feature is, let's say, plug and play. You can just bypass it if you only want to send OSC messages. So I will give a bit of the vocabulary we use to describe the temporal events. Everything that is horizontal, we call them time constraint, because it means that some time must pass between this point and this point. And time constraints can be bounded, like here, so they can have a minimum, maximum, or even just have a fixed duration, but also be entirely or partly unbounded. So you could say, I want to play only after 5 seconds if something happens. Then we have basically 3 graphs that are incorporated in the same user interface. So the temporal graph, which is given by the alignment of time constraints. And then we have a logical graph, that is conditions. So here, for instance, in white, this is a time event. So time event, and in between a time node. Time node does synchronization. So this means that when we reach this point, this starts and this starts. And the difference is that time events can carry conditions. So basically, when you reach this, your condition here is evaluated, and your condition here is evaluated. And if it's true, this follows. If it's true, this follows. So it's not if else, it's more like if else, but for each case. And finally, the primary mean of extension of iScore is the notion of process. So basically, you have boxes, and you can put basically any code that you want in the box. So here an automation, but most of the software is implemented like this, and it's recursive. Even the main temporal organization is a box itself. So my work was also concerned by adding this process. So we have sound file reading, real-time input, effect chance with the Faust programming language. So Faust is a language developed at RAM, and not only that allows to specify very precisely DSP processes, and it compiles them on the fly with high performance. And an interesting feature is the notion of audio graphs. So we can take some audio at some point and process it at 2 different points, but always mostly within the temporal metaphor. And finally, mixing. So yeah, the point is that we have a flow graph, but we want to have the focus of our software on the temporal aspect. So it's not like, for instance, Max, where you see the flow graph, and if you want to do temporal stuff, well, you have to cheat a bit and, well, use P8. So current limitation of the software is the graph creation is static, so you can not modify it at runtime. You have to do your stuff and then press play, and then once you press play, you can change it. You have to press stop and restart. So this is a current limitation. And about mixing, so we do mixing, of course, recursively, and we start from the process. They mix themselves in their parent, and the parent of a process, like I said, is a constraint. And in the same way, the parent of a constraint is a process, and in the end, you get your 2 or more audio channels that you feed your sound card. So it's all going upwards towards the hierarchy levels. Okay, so I will be doing 2 short demonstrations. So the software is alpha. So I hope that there won't be any crashes, but I cannot promise. Okay, I hope that sound won't be too loud. Okay, so this is iScore. And this is the score, so I will explain while it's running. I just have to check that something is working. Okay. Yeah, it's working. Nice. Let's go.
Known as the hummingbird hawk moth, or sometimes the humming moth, is a species of Sphingidae.
Okay, yeah.
So here I can trigger how I want, and I can also trigger automations in runtime, basically. So everything is very dynamic. Here I have a loop. The whooshing sound is not very loud, and this will run like for eternity. So unless I press stop, it will keep running. And here we have an automation that will it will start from the running value, basically. So it allows to have automation that can change their start to interpolate between different runs. You can use all the easing function for interpolations. And here I will have 2 loops. So a very small loop to give a granular feel, and another loop that I will trigger and re-trigger. Okay, so I can... hey, come on, baby. So I can just re-trigger it, and it will be much better with an MPD or something like this. And finally, here I have a mapping between a gestural control trigger, the hot hand, and well, the first instrument. So I can move on like this, and this is the end of this small example. And I will just replay it a second time to just show a funny feature, which is that you can also basically
known as the hummingbird
alter the speed of everything at runtime.
Okay, yeah.
And for instance, I can also just make something
Firefighters,
shorter.
Emergency personnel responding to toxic spills.
So everything can change of speed at runtime, and it's all hierarchic, with this sole limitation that this won't work if you have real-time input, because of course you cannot go faster than the current rate of input. So there is a small algorithm that recursively deactivates the audio slowing algorithm for this. And then another small example with materializes, sends, and return. I hope I'm okay. Okay, perfect. So here we have a loop with multiple sounds, so a loop and a hierarchical scenario, which is not in rhythm at all, I'm sorry. And here I have, so this is send, and there is a return that adds some reverb. And same here, I will just add some filter, so a bit more mid-level. And finally, some synthesizer. So this uses Faust again, and you can, well, you know, just control your synth like you would anywhere else. So you can control stuff like this at runtime. And all the parameters are also available from network. So thank you, good night. And you can just, yeah, change stuff like this at runtime. So quickly, what misses? You cannot record anything for now. It's really, you have to use another software to do this. we would like to use the real-time input but delayed. So you sing and then 5 seconds later you reuse it without cheating by using a delay plugin or something like this. MIDI integration, for now you can just get not on, not off, and control change messages, not very fun. And the problem of temporal signature, if you want to do some rhythmic music, you really want to have that 4/4 on which synchronize stuff. You can hack it by creating a small loop that will send a message every few milliseconds, but it's better if it's embedded. And finally, I added this morning after the presentation of Tron because I'd really like to get some spatialization going on. And so some reference. And I put yesterday a release on the website, but it's only for macOS, and I couldn't test on other computers. So please do bug reports if it crashes or something like this. Thank you very much.